Welcome back, students. So we were discussing about the posterior inferior surface of the stomach. Okay, just enumerating the parts of stomach. So this is the cardiac end. Yes, so this is the cardiac end. This was the greater curvature. This was the lesser curvature. Yes, so we have divided this as the fundus. Yes, another imaginary line. This as the body. Then we had the pylorus. Okay, so the lesser curvature, the greater curvature. Yes, so these were the parts. We have seen what were the relations of the anterior superior surface or the anterior surface. Posterior surface. Okay, posterior surface when you are dealing. So posterior surface will be towards your side in this video. Okay, so anterior superior surface was towards me and posterior inferior surface. So posterior surface in the previous section of dividing the topics, dividing the subtopics, we were said that the posterior surface is also referred to as stomach bed. So in the previous sessions of peritoneal cavity or peritoneum when we were discussing, I have said that if you are taking a cross section, I am showing a miniature diagram for you to have that concept recollected. Okay, so if this was the liver, okay, if you are taking a transverse section and if this was the stomach and this is the spleen, okay, so please do remember, so this is the falciform ligament, okay, which was connecting, okay, this is a falciform ligament which was connecting, okay, the liver, then you have your stomach, spleen, okay, similar way, this was how we have drawn, okay. So if you remember, the part which was behind, yes, the part which was in front of stomach. So this is stomach, liver and spleen. In front we call it as greater sac. Okay, we call it as here. The part which is behind, the peritoneal cavity, which was initially, if you remember, because of the rotation of the river, the left and right change has been to anterior and posterior. We call the part behind as lesser sac. So lesser sac is a small part or a small part of peritoneal cavity which is bound behind by the stomach. So if you are just lifting the, okay, you are just lifting the stomach to see its posterior surface, you will be able to see the lesser sac part of it. Since this is forming, okay, like a bed or a bursa to the stomach, you also call this as omental bursa. Okay, this lesser sac is also referred to as omental bursa. Okay, so lesser sac also referred to as omental bursa, and this is in relation to the posterior inferior surface of the stomach. Just behind this lesser sac, yes, just behind this lesser sac, there are many retroperitoneal structures, okay, there are many, yes, everything behind the peritoneum, yes or no, so everything behind the parietal peritoneum will be there are certain retroperitoneal structures which will be forming the bed for the stomach. That is why the structures which are beneath this omental bursa will be called as stomach bed structures. Okay, stomach bed structure. So if you try to enumerate it from the posterior abdominal wall, okay, so you can see that the first and foremost will be the left crus of diaphragm, left crus of diaphragm. Okay, so diagrammatically if you want to represent, okay, so you have your diaphragm, yes, this is how, this is the right crus, this is the left crus, okay, in the middle, okay, previously in the, if you just recollect or go through the diaphragm, the diaphragm video, it will be clear for you. There are two crura for the diaphragm, left and the right. So this is the right side, this is the left, okay, just relation to it, okay, just related to it, you have the left kidney, okay, very closely related to it, you have the left kidney, and through them, if you remember, you have the abdominal aorta, yes or no, the thoracic aorta continuing as the abdominal aorta, you have renal vessels on either side reaching it, okay, so anything, okay, your posterior surface, so you have your stomach here extending like this, okay, so you can take the vertebral level that the stomach is extending from, okay, you can take the level that the stomach is extending from the T12 level to L1 level. Oh, so if you are taking this T12 to L1 level, so the first structure in relation to the posterior surface is left crus of diaphragm. Then you have the left kidney as I have shown in the figure. So left kidney in relation to left kidney on its apex, okay, in relation to left kidney on its apex, you have a pyramidal shape left suprarenal gland. So because the stomach is on the left side, so all these left structures are related to it. Left suprarenal gland. Yes or no? Left suprarenal gland. A small part of, okay, you can say a very small part of spleen, okay, a very small part of spleen, not the whole part. So you have to remember that spleen is an extra peritoneal tissue and it is covered by peritoneum. Only a small part of spleen is related to posterior, but major part covers what? The anterior surface, a small part of spleen, okay, the left kidney, left. Then you have the left psoas major muscle, psoas major muscle, okay, psoas major muscle as you are going more behind, okay. So the left crus, left kidney, left suprarenal gland, then the spleen, then you have the left psoas major muscle, and in relation to the psoas major muscle you will have your left sympathetic ganglion and all those things. So please remember these major structures which are forming the stomach bed. Okay, so as you are going more towards the left, okay, as you are going more towards the left, okay, you have this transverse colon anteriorly, so you also have the left colic flexure related to it, okay, the left colic flexure, okay, left colic flexure where your transverse colon continues, okay, down as the descending colon. Okay, so these are how you have the structure. So, but the major structures forming the stomach bed beneath the omental bursa are crus of diaphragm, the kidney, the suprarenal gland, the spleen, the psoas major muscles with its associated nerves and the sympathetic plexus and the left colic flexure. So, these are all the structures which are forming the stomach bed. So, we have completed the location, relations, parts, okay. Please remember the stomach bed part there. Then let us now continue with the blood supply, nerve supply and the lymphatic drainage, okay. Then recapitulating all the parts of the stomach. Yes, so please remember the lesser curvature, the greater curvature, the fundus, body and the pylorus. So the major blood supply, blood supply to the stomach is through the celiac trunk. So if you all can recapitulate, the abdominal aorta gives some unpaid branches in the abdomen. These include the celiac trunk, the superior mesenteric and the inferior mesenteric. The celiac trunk is the one which majorly supplies the derivatives of foregut, the superior mesenteric to the derivatives of midgut and the inferior mesenteric to the derivatives of the hindgut. So these are the three major arteries which are going to supply your viscera in the abdominal cavity. So the celiac trunk is going to supply all the derivatives of the foregut. So if you remember, the derivatives of foregut are your esophagus, the stomach, the first part of the duodenum, the second part of the duodenum, yes, the liver, the spleen, all these are derived from the foregut. So this is being supplied by the celiac trunk. Before understanding the blood supply here, you need to understand that the stomach is held by, or it has some ligaments or some peritoneal folds attached to it. So you need to understand that and then understand why what these peritoneal folds are helping. So around the lesser curvature, going back to our signature embryology figure, where you understood that, okay, you have your stomach here which is being hanged by, by two mesogastria. What are they? The ventral mesogastria and the dorsal mesogastria. In the ventral mesogastria, you have development of liver. In the dorsal mesogastria, you have the development of spleen. So previously also I have mentioned it during the peritoneum class. The ventral mesogastrium which is connecting the liver, okay, and the anterior abdominal wall will become falciform ligament. Okay, this will come many times in our lectures so that you can have this memory, okay, memorize it easily, okay. Whereas the communication between, okay, the liver and the stomach forms the lesser omentum. Okay, so we have said that there are double layer or double fold of peritoneum which will be holding the viscera in the abdominal cavity. So along the lesser curvature, okay, you have the lesser omentum connecting the porta hepatis, okay, connecting the porta hepatis of the liver to the lesser curvature. So we already have seen that why should there be a double fold of peritoneum. This double fold of peritoneum is for the passage of blood vessels, for the passage of nerves. Yes or no? There need to be some conduit or some way for the supply, okay. So you have lesser curvature connecting the liver and similarly posterior or the dorsal mesogastrium, okay, dorsal mesogastrium. I have said that this dorsal mesogastrium which is connecting between the stomach and the spleen, the part of it, okay, will become gastrosplenic ligament. Yes, splenic. Why we are calling it as ligament here? They thicken, okay, in the adults they thicken. okay, becomes gastrosplenic ligament, and a major part of it becomes greater omentum. What does it become? It becomes greater omentum. So, the greater omentum is attached like a, so you can see that it is attached like a apron, okay. So, it is attached throughout like an apron, okay. So, it is attached throughout like an apron along the greater curvature. So, if I am taking a cross section, this way or a transverse section this way, okay, just imagine the liver to be here, okay. So, this would be the liver, okay, this would be the stomach, okay, this would be the spleen, okay. So, you have your falciform ligament here, okay, then it is splitting, the liver is being split up, then you have your lesser omentum, then you have, yes, your anterior layer and posterior layer of lesser omentum covering the stomach, okay, this extends behind to cover up the spleen, okay. So, this forms a gastrosplenic ligament, okay. If you go down, then you see that there is extension of an apron like structure which is the greater omentum. So, the double fold of peritoneum which are around or which are holding the stomach include, yes, the lesser omentum here, yes. So, this is the lesser omentum, okay. Then you have the greater omentum here, okay, greater omentum here. Then connecting, okay, spleen, you have your spleen, connecting the spleen, yes, connecting the spleen with the stomach, you have the gastrosplenic ligament. So, you have to write. So, if you are being asked a question of what are the ligaments or what are the peritoneal folds attached to the stomach, you need to write lesser omentum, greater omentum, the gastrosplenic stomach. Sometimes, okay, the posterior part, posterior or superior part, okay, the above part, on the posterior side, the stomach is, it is said that the stomach is bare. Bare means it is not covered by peritoneum. At this point, the stomach is attached to the diaphragm with a gastrosplenic ligament. Even that is peritoneal fold. So, you can also write there is another ligament which is called as gastrosplenic ligament, which is again a double layer or fold of peritoneum. So, what are all the ligaments which are attached to the stomach? You need to mention the lesser omentum, the greater omentum, the gastrosplenic ligament between the stomach and the spleen, and the gastrosplenic ligament which is between. Phrenic is always, please remember, it is diaphragm. Gastrosplenic ligament. Okay. So, understanding this, let us now understand the blood supply. So, I have said that at the level of T12, please remember, at the level of T12, okay, the celiac trunk arises from the abdomen in the retroperitoneum, okay. This celiac trunk, okay, this celiac trunk gives rise to directly, okay, it gives rise to left gastric artery, the branches it gives rise to is left gastric artery, splenic artery and a common hepatic artery, okay, gives rise. So, the first three branches of celiac trunk are left gastric artery. So, at G12 you have celiac trunk, okay, celiac trunk, this celiac trunk gives rise to, yes, three branches, left gastric artery, okay, then you have the splenic artery, then you have the common hepatic artery, common hepatic artery. This common hepatic artery, we will first see this common hepatic artery again divides into, or it gives rise to, okay, a left gastric artery gives rise to a left gastric artery, a hepatic artery and a gastroduodenal artery. So, it again divides into three branches, common hepatic. What are these three branches again? Okay, the right gastric artery, okay, then the hepatic artery itself, then a gastroduodenal artery, okay, gastroduodenal artery, okay. This gastroduodenal artery, okay, this gastroduodenal artery which I have done again divides into two branches, okay, it again divides into two branches. What are these two branches again? Okay, one is superior pancreatico-duodenal, duodenal artery. So, you can see that as a name indicates, gastroduodenal, something to stomach and duodenum. Then again superior pancreatico-duodenal, something related to pancreas and the duodenum, okay. And the right gastro epiploic artery, Okay, so don't get confused yourself here. So celiac trunk initially gives 3 branches. What are these 3 branches? The left gastric artery, the splenic artery and the common hepatic artery. Common hepatic artery again divides into 3 branches, the right gastric artery, the hepatic artery and the gastroduodenal artery. The gastroduodenal artery again gives rise to superior pancreaticoduodenal artery and the right gastroepiploic artery. So what is happening here? Let us see. Both the left gastric, okay, and the right gastric, okay. So this is the left gastric, yes or no, and this is the right gastric given by the common head. Both of them enter into the lesser omentum and anastomose here, okay, and supply the lesser curvature along the lesser curvature, okay. So the right gastric and the left gastric, okay, they are anastomosing with each other along the lesser curvature and within the lesser omentum. In a similar way, I have said the second branch is the splenic artery. Splenic artery, okay, splenic artery is a tortuous artery, okay, which passes above, okay, which passes above the pancreas and is relation to the posterior inferior surface. In this case, okay, in the stomach bed, which I have dealt in the previous session, we have included which are going to form stomach bed, yes, structures which are going to form the stomach bed. What have we included? All those structures which now we can increase the length here. I have said that it is the left crus of diaphragm, okay, so we can increase the list, left crus of diaphragm, yes. Then you have, yes, what do you have? Then you have your, once you have left kidney, just over the left kidney, I am enumerating it for you to recollect it again. Then you have the left suprarenal gland, yes or no? Yes, these were what we have discussed, okay. After left suprarenal gland, okay, I have said there is left psoas major muscle. Yes, left psoas major muscle, okay. Along with this, okay, along with this, the stomach bed, okay. Stomach bed is formed by the splenic artery here. You can also see the splenic artery, okay, splenic artery. So this will be clear when we are dealing with the duodenum also. So the splenic artery, okay. So if I just want to draw a small miniature diagram and zoom it like this, okay. So this is how you have the pancreas extending here, you have the spleen here, okay. So you have your celiac trunk, okay. So celiac trunk here, so you have the splenic artery extending just above the pancreas. So in the list included in the stomach bed, you have the splenic artery, then the body of pancreas, okay, body of pancreas. I just wanted to include this. Why? Because it will be easy for you to understand the blood supply here, okay. So along with the left crus, left kidney, left suprarenal, psoas major, splenic artery, a small part of spleen, you have body of pancreas forming the part. So this is a miniature diagram which is showing you how the pancreas is done. Because pancreas and duodenum are retroperitoneal, okay, behind. So you have the body of pancreas forming the part of stomach bed. And splenic artery, I have told you that it is one of the main arteries, okay. So one of the main arteries which is passing posteriorly or relation, or so it is one of the structures forming the stomach. This splenic artery is tortuous. After reaching the greater omentum, okay, from the posterior, it enters into greater omentum and divides into, yes, and it divides into the splenic artery, gives a branch called as left gastroepiploic artery. So this is the left gastro. This left gastroepiploic artery anastomoses with the right gastroepiploic artery, okay. From where did we get the right gastroepiploic? This is from the gastroduodenal artery. Where did we get this gastroduodenal artery from? From the common hepatic artery. So gastroduodenal, which is branch of common hepatic here, gave rise to gastroduodenal, which again divided into superior pancreatico and the right gastroepiploic. So this right gastroepiploic and the left gastroepiploic reach into the greater omentum. They reach into the greater omentum and anastomose and start supplying the greater curvature and major part of the anterior and posterior surfaces of the stomach. So here the major supply is by the right and left gastric arteries, which are anastomosing in the lesser omentum, and the right and left gastroepiploic arteries, which are anastomosing in the greater omentum and supply. Splenic artery on the posterior surface, since it is forming part of the stomach bed, it starts giving some short gastric arteries. So these also form the blood supply, short gastric arteries. This also form the blood supply to the artery. So if you are asked what is a blood supply to the stomach, you will tell that along the lesser curvature. Okay, so along the lesser curvature, you have anastomosis of right and left epigastric arteries. Left gastric artery is a branch of the celiac trunk. Right is a branch of the common hepatic artery. Both of these anastomose in the lesser omentum and supply along the lesser curvature. In a similar way, there is a right and left gastroepiploic artery. The left gastroepiploic arises from the splenic artery, which is a tortuous artery which arises from the common hepatic artery. This left gastroepiploic and right is a branch which is arising from the gastroduodenal. These two anastomose around. They anastomose around the greater omentum and supply the stomach along the greater curvature. Splenic artery also supplies some branches which are called as short gastric arteries. Just 2 points of references in relation to the lymphatic drainage, the venous drainage and the nerve supply of the stomach. We will just have 2 points each. Okay. The remaining are too high to your standards. So what I feel is just have 2 reference points. So coming to the venous drainage of stomach, okay, all the veins, okay, you should say venous drainage. So all the veins of the stomach do accompany the arteries. Okay, so the left gastric artery has a left gastric vein, the right gastric artery has a right gastric vein. So just remember that all the arteries which are supplying will have veins accompanying them. And one special thing is all these veins will drain into the portal vein. Okay, so this venous supply, the veins which are having a similar accompanying the arteries will have this same name, and all these veins will be draining into the portal system. So the venous drainage of stomach is received into the portal system, forming portocaval anastomosis. Around this point, okay, I just want to mention another point. At the lower end of the esophagus, okay, the left gastric vein, okay, forms anastomosis with the systemic veins. Esophageal veins are systemic veins forming a point of portocaval anastomosis. So during portal hypertension or during obstruction of portal vein, what happens? These veins which form an anastomosis at the lower end of the esophagus, very close to the stomach, form something called as esophageal varices. Okay, called esophageal varices. So you remember, you can see that this esophageal varices bleed, and people who have this portal hypertension or postal obstruction will vomit blood. Okay, so around the lower end of the esophagus or upper end of the stomach, that is around the cardiac region, you have portocaval anastomosis. And always remember that all the veins accompany the named arteries of the blood supply of the stomach. Okay, this is regarding the venous drainage. Coming to lymphatic drainage. Okay, so we will just deal with only 2 points here. So coming to lymphatic drainage, okay, again let us draw a stomach. So please be clear while drawing your figures. Figures themselves will let you understand many things. So if I am drawing an imaginary line separating the stomach into a right half and a left half, of major part towards the left and a small part towards the most of this left part is drained by group of lymph nodes which are referred to as pancreatico-splenic. Okay, they are pancreatico-splenic. Okay, splenic lymph nodes. Okay, so pancreas, that is both the spleen as well as pancreas will also be drained by these lymph nodes. Coming to the right side, okay, there are a set of group of lymph nodes in and around the left gastric artery. These are called as left gastric lymph nodes. Okay, so the upper part, especially from the lesser curvature, it is into the left gastric lymph nodes, whereas the lower part is into a group of lymph nodes which are very close to the liver, which are called as hepatic group. Okay, so hepatic lymph nodes. So there are 3 groups of lymph nodes. Okay, the pancreatico-splenic. Okay, then you have the left gastric group of lymph nodes, then the hepatic group of lymph nodes. All these 3 help in drainage of the lymph node. And please remember at this point, the lymphatics of stomach, The lymphatics of stomach are not continuous with the lymphatics of duodenum. This is due to presence of a septum, okay, in the mucosa, okay. When you are reading the microscopic structure of the stomach and the duodenum, around the pyloric end, around the periodically sphincter, there is barrier, okay, for the lymphatics of the stomach and the duodenum. So, lymphatic of stomach, please remember in simpler words, lymphatics of stomach do not continue with the lymphatics of duodenum, whereas the lymphatics of stomach do continue with the lymphatics of esophagus. That is why in gastric carcinomas, gastric cancers, stomach cancers, the spread of gastric cancers is towards esophagus but not towards the duodenum. This is one of the important point in related to lymphatic drainage. Now coming to the nerve supply. Okay, nerve supply. So you all know the viscera has to be supplied by autonomic nervous system, yes or no? So you have a sympathetic nervous system and a parasympathetic nervous system. The sympathetic nervous system of stomach, okay, the sympathetic nervous system of the stomach is from the level T6 to T8. So T6 to T8 supplies, okay, sympathetic, the ganglion, the thoracic ganglion autonomic nervous system is from the level of T6 to T8, okay, and the pain of stomach is usually any ulcers in the stomach, any pathology in the stomach is felt around this T6 to T8 level. Coming to the parasympathetic, which plays a major role here, parasympathetic nerve supply, okay, parasympathetic nerve supply to the stomach is through the vagus, nerve or the 10th cranial nerve. Yes, 10th cranial nerve. So we all know that stomach, okay, again we will draw a neat diagram of stomach here. So stomach has an anterior superior and a posterior inferior surface, okay. So there is an anterior vagal trunk, okay. In a similar way, I will draw it with another color. There is a posterior vagal trunk, okay. So previously you have seen, again go back to your development, a fusiform dilatation. So usually there should be a, yes, towards the left vagus and towards the right vagus. Because of the rotation, what has happened? The left has become anterior vagal trunk and the right has become posterior vagal trunk. Okay, the importance of these vagal trunks are the anterior and posterior vagal trunks after reaching the stomach, they divide. Okay, they divide and ultimately supply the mucosa where the gastric juice needs to be separated. The shortest nerve, okay, the shortest nerve or the least branched part of vagus nerve is referred to as nerve of lateral jet. As of now, this theory is not accepted, but there is something called as the smallest branch of vagus nerve which supplies, okay, which supplies the oxyntic cells. What are these oxyntic cells? Acid producing cells from the stomach. These oxyntic cells are being supplied by the smallest nerve of lateral jet. So surgeries, vagotomies, okay, cutting of the vagus nerve, okay, then incising this nerve of lateral jets, okay, all this is being done to decrease gastritis or excess production of gastric acid. If you can see that, if you can appreciate that the GIT right from the stomach has 4 basic layers. So basic build-up of your GIT layer from outside inwards are serosa, yes, that is nothing but your peritoneum which is covering it. Then after serosa you have the muscular layer, or you can also call it as muscularis externa because it is outer. Yes, just beneath or inner to it you have the submucous layer, yes, the submucosa, and inner to the submucosa you have the mucosa. Okay, so in the stomach, okay, you have this mucosa, okay, so you have this mucosa in the stomach which has many glands called as the gastric glands. These gastric glands open out through gastric pits. This is what you need to understand. Within the gastric gland, you have 2 important types. There are many cells, but most important type of cells are your chief cells, okay, and the oxyntic cells. Okay, what do these chief cells secrete? These chief cells are, you can also call them as pepsinogen cells. Okay, these chief cells are pepsinogen cells, secrete pepsinogen, whereas your oxyntic cells secrete the HCl. Okay, so the vagus plays an important role by acting on this oxyntic cell. So this nerve of lateral jet innervates up till this gastric glands and up till this gastric pits, okay, initiating the production of gastric juice. Whenever there is excess production of gastric juice, you are calling it as your daily terms, the acidity, the gastritis which you are calling. This is due to an imbalance between the mucus secreted by your gastric glands and the HCl, acid secreted by your because of this imbalance. So, in order to prevent, okay, so because of the excess activity of this gastric juice in the stomach, there is very chance of production of gastric ulcers, okay. Initially, there will be erosion or there will be spillage or spoiling of your mucosa, which will be leading to erosion. Erosions then lead into ulcers, gastric ulcers. So, in order to cure gastric ulcers, the latest technologies which are being followed are vagotomies, okay. So, they can be truncal vagotomies where the trunk of the vagus can be cut down, okay. Vagotomy is cutting down of your vagus, okay. So, they can be truncal vagotomies or they can be branch wise, okay. The nerve of lateral can also be incised, okay. It can be cut to or its connection can be removed for decreasing the gastric acid secretion. So, as for the secretion of gastric acid, you have the importance of parasympathetic, which is by the vagus nerve, and during gastric ulcers, production of gastric ulcer or excess production of gastric fluid, you need to cut down or cut short the vagotomies. Commonly done one are called the truncal vagotomies. Why? Because there are two trunks, the anterior trunk, posterior trunk, which are derived from the right and left vagus nerves.